Hello everyone, it's June the 1st. Wow, we're entering a new month. Let's take a look. We have 3 notifications, and none of them of concern. All right, take a look at today. All right, first one, max area of island. Oh, look at that. We're given m times n binary matrix. An island is a group of ones. Connected directionally, you may assume all 4 edges of the grid are surrounded by water. The area of an island is the number of cells with a value of 1 in the island. Return the maximum area of an island in a grid. If there is no island, return 0. So the maximum is this one, 1, 2, 3, 4, 5, 6. And because it's connected horizontal or vertical, so these two are not connected. The answer is not 11 because these are not connected. Yeah, must be connected 4 directionally. That's a 0. Okay. Interesting question. Actually, I like it. So basically, we need to identify islands, right? Apparently, we need to go visit each cell. When we hit a cell that is an island, a piece of the island, then we're gonna look around, right? We'll look around. Like for this one, we look around, and there's nothing. Oh, I think it's hold up. So we hit here, right? And then every time we hit, we can say like turn to -1, so we know we hit it already. And we're gonna look around 4 directions, and nothing. So this one on the 1. Keep going here. 4 directions. Well, this one cannot go, so go this. This one is a go, so we will. So every time we hit one, then we're gonna start a DFS, a backtracking DFS. So we go here, right, and then we look around, and no go, no go. This one already visited, and this one is a go. So we hit here, no go, no go, no go. Hit here, no go, no go, no. Oh, we have nothing to go. So we got 4, and then after we're done, we basically come back here. So we keep looking, right, and then we hit here. It's always -1, so we don't do it again. Keep going here. All right, look around. Now we have 2 options, right? 2 options. Doesn't matter. We pick any one. Let's say we're gonna pick this one. So we go here, right? And then we go is no go. No go. We go back. All right, we go back and we have another option. So we go. Is that now we don't have to backtrack. No, there's no like a real backtracking part. We just visit every single one that's connected. But think of these are just like a graph. We just traverse through the graph, and we go here, and every time we hit one, we just increment a count. And go back, coming down here, no go, no go, coming down here, no go, no go, coming down here, up, done. And then after actually all we're done, we can just go back until we hit the first one, and then we return. So this thing will return the values 4, and keep going. This one is the same. Blah, blah. We hit here, we can go through everything, and we won't hit this one. So yeah, I think this is just going to be traverse through the entire grid, and when we hit a 1, we do a DFS, we report the number, and that's it. Okay, I think it's pretty straightforward, but it's a new day, so we have to make direct. What is our folder name? I don't remember my folder name. I do the folder name as month challenge. Okay, make directory 06. Wow, we have been doing this since August last year. Oh, 2 more months. We're gonna hit a full year. Interesting, huh? So it's gonna be 06, and this is gonna be this one. Okay, and then again, this one will have to change 01, 06, and 06. There we go. That's the one. Okay. So wait, why is it so small? There we go. V, delete this and copy and paste this. All right, so we're gonna just say DFS. Let's do DFS first. All right, so I and J, right? I and J is going to be the coordinate, and I want to return the, I want to return, and that shall be it. So we just say return, we're going to return an int. So it's how many how many cells in total, right? So we just say if grid I and j is smaller or equal to 0, then we'll return 0, right? It's nothing. Otherwise, we're gonna go 4 directions, right? 4 directions. So we're gonna say for dij in. So dij can be 1 1, right? 1 1 is going where? 1 1. Let's go just up. Go up first. Up will be go up. Actually, this is nothing is 1 1. Go up will be 0, right? So on the I, on the row, no, on the row is -1. On a column is a 0, right? And go right. Go to the right will be 0 1, and go down will be 1 0, and go left is 0 -1. We actually can do be like here. If okay, we're also gonna say mn equals len grid, that's m, and len grid 0. So we're gonna say here if or if not, now if I is smaller than 0, or I larger equal to m, or j smaller than 0, or j larger equal to n, so it's out of the bound, or this, that will return 0, right? We don't do anything. Otherwise, we do this, and we're going to say area, right? Area is going to be 0, and I'm going to say area plus equal to DFS I plus DI, J plus DJ. So I'll go to the next one, and then we'll accumulate everything, and then we're going to return area plus 1 plus myself, right? So that's the DFS part. Once the DFS part is done, oh, hold on, one more thing. So, and then we'll have to also change grid ij into -1. That means we have visited it already, right? Into -1, and then we visit the next one. So that's DFS. When DFS is done, so we're gonna say for I in range m, for j in range n, right? And then we just say res equals to 0, right? And we say if grid ij is larger than 0, right? Then we're gonna say res equals max res DFS ij, right? DFS ij, and we're gonna return res. All right, let's see if this one is correct. Not sure. So I have 2 test cases for us. I would love to have a bit more, but I think this one is pretty comprehensive. We got almost all the conditions. Oh man, this one, I have to clean it up. All right, let's create a new one to clean up this thing. So the way I want to clean up, of course, is all about, there we go. Now we can put it here. This one will return, I think, 6. Yep, 6. And the next one is easier. The next one, there's no island on this one. So this one is 0, right? Okay. Now we're gonna go to grid. Change this into max area. Grid. All right, let's try it. Oh, we passed both. Time to submit. So let's go here. All right, submit. Pending. Judging. Accepted. Good. We got this one. So it's not too complicated. So basically, we say it is whenever we reach a part of an island, we run a DFS to traverse through all the cells inside the island. This allows us to compute the total area of this island. Furthermore, each cell visited will be converted to -1, such that we will not revisit it. We will not visit it again later. So total runtime is OMN, where M is the number of rows in grid and N the number of columns. I mean, the DFS just means, I mean, we visit each one once, and actually we have to add all this. The maximum is still like 2 times mm, so I think it can still say it's mm. And the runtime, let's take a look. The runtime is, oh, so bad. Why is it so bad? We had 176 milliseconds, which means that tells me that there might be a, actually I don't know, there might be a better solution. 176 milliseconds, 6, not 5, like 11% ranking. All right, so take a look. What's the majority? In visited. This is the same thing, right? I mean, it's pretty straightforward. They use visited. And we changing. It's the same, right? I think it's the same. 40. That's fine. Let's take a look. Probably have solutions for this one. Yep, as expected. It's a typical medium question, I think. It's a typical medium question. Yeah, it's typical medium level. This is what I think a medium level will be like. Like it requires some trick. How a trick? Not just like skills, right? That's like 1 or 2 skills. That's a medium question. All right, DFS, recursive. Oh wow, that was iterative. Oh, it's the same. It's just write it in one line. Oh, okay. Oh, okay. Oh yeah, we don't have to do this because we already have the check here. So it's like this is redundant. That's true. Scene.add. No, we just by changing. Okay, let's make it a little bit nicer. This one we don't have to change. This one is the same. I like it to do it this way. But this one we can change. That's for sure. So let's make it shorter by directly return. I can say return max for actually we can just copy this, right? So max for this and for j, right? For j, and we just say DFS INJ, right? It'll be shorter here, and here can we make it even shorter? That is about it, I think. We can make it short. So we can return. We can say sum, right? Sum DFS this for this for the this. Yep, can do that. And then we return 1 plus sum. So we also shave another line, and we don't need this. Yeah, I think. Well, if we want to do this, why? Let's just make it more explicit. So we're just gonna be -1 j, right? Yeah, 4 directions. That's fine. And then there's gonna be I j plus 1. No, it's not comma. It's plus sign. And plus. What's the next one? 1 0. So we're gonna add 1 here. 0. And the last one will be 0 minus 1. So 0 minus 1. So we don't need all of these. And yeah, I think this one shall still work. Yep. So yeah, let's submit this one as well. I think it's going to be faster. No, it's the same. It's exactly the same solution with a nicer interface. I thought you run slower, but anyway, yeah, that's it. Straightforward, DFS, easy, 4 lines. Yeah, it's probably 4 lines. Wow, what the grid.pop. Oh, he's using complex numbers. Wait, what the hell? Complex numbers. So use a complex number to represent each cell. Okay. Okay. And then what? And then for k in range 4, that's the 4 directions. And j to the kth power. J to the kth power is I'm trying to understand. Row. So j, the imaginary part is the column, and j, 1j. Okay, it's 1j to the kth power. So if it's even number, then that's a -1. If it's odd number, that's a +1, right? So we have z +1 or z -1. But then that just go like in the hard, just changing rows. How about changing column? How do we change columns? Map area. Okay, we map area set grid. Why do you do set grid? Isn't this gonna be, each one be different? Oh, well, it's actually not, because j can be 0. If j is 0, then it will be the same. J is 0. What happens when j is 0? That's the first column, right? No, it's the first row. J is 0 is the first. Hold on. No. J is 0. I is row. J is column. J is 0 is the first column. That's fine. J and then 1, 2, 3, 4. I don't understand why you do set grid. And then map area. We put the area, this function, on this, each one of them. So the grid is a dictionary. What happens when you do set on a dictionary? Good question. That's the keys, right? You do set on dictionary, you get a keys. It's always an enjoyment to read Mr. Pachman's solution. Yeah, do a set. You get all the keys. You can just do keys. And each one of them, a z, that's the coordinates, right? And grid.pop, z is 0. Grid.pop. So we're gonna pop z if it exists. If it doesn't exist, we're gonna do 0. Otherwise, we say 1 plus sum this. Okay, 1 plus sum area. So this is the part I don't understand. The k in range 4. K in range 4. I'm only changing horizontally. How do I change vertical? How does the hold up. So okay, let's do this. 1j, right? 1j 0. 0th power. That gives us 1 plus 0j. Okay? 1 power. That gives us, so that's 1, 0. That's 0, 1. That's 0 minus 1. No, we skip it 2. That's minus 1, 0. Oh, yes. Oh, I see. Oh, I see. So the imaginary, right? So it's actually I in math, right? So if I do 0 power, that will get 1, which is a 1, 0, yeah? If I do 2 power of 2, that we get a minus 1. So that's minus 1, 0. If I go 3, we get as a minus j, it's a 0 minus 1. When we get 0, 1, 1, that's a j, like a 0, 1. So I have 0, 1, 0 minus 1, 1, 0. Oh my god. That is correct. So we go through each one of them. So it doesn't really check. So it doesn't care. It doesn't really check for whether it has been visited or not. We just visit everything one more time. And when we hit here, Let me check grid.pop z. Oh no, it is. He's removing it. He's removing it. So if you have visited already, he removes it. He removes it by popping it, right? And it will pop. That means like I have visited already. I have visited z, and I'll pop z. If when I pop z, the result is a 0, then that's a false. So we don't keep going. If z doesn't exist anymore, that means we have visited already. Then we get a z, and then we get a 0. Then we don't do it anymore. Otherwise, oh my god, oh my goodness, oh my goodness, holy moly. Yeah, yeah, I checked that one as well. I think that's his cube. Yeah, that's his cube. Yeah. I read this once, like I mean a few months ago, and I got just completely blown away. He has a um, method named after him, Classic Pokemon. I mean, I used to do cubes, but not really at this level. Just very very early, like very simple cubes. But yeah, but definitely don't bother. Yeah. Wow. Yep. I want to write something. I really want to write something. I mean, this is eye-opening, right? This is eye-opening. Yeah, the pinnacle of human intelligence. I shouldn't say this. I mean, it's just, yeah, I just eye-opening every single time. Yeah, unbelievable, unbelievable. So, but I mean, this gives it's a trick, right? Granted, it is a trick, but it's a very, very neat trick. By doing this, it is possible that we don't have to set up other ways in order to check if if a node has been visited already. So I think from a few weeks ago, no, from a few days ago, right, we talk about using a bitmap to represent. Actually, this we can use bitmap, right? We can use bitmap. Actually, we cannot use bitmap. We can only use bitmap to talk about the direction, but the actual position is not a bitmap. So we talk about bitmap to represent a state of finite combinations, like combinations of finite elements, right? If we have a combination of finite elements along like the positions in how should I put it? If I have finite number of options and they need to be laid out in a certain order, right? And if we want to represent that state, we can use bitmap. It's very easy to use bitmap, and we can check if the state has when we check the state, we can use or exclusive or whatnot to manipulate it. So that's one trick. But here what we see is for a matrix, right? For the coordinates on a matrix, a very smart and elegant way to represent the state of a pair, right? This is basically just a pair, a state of the pair. And using this tool, we can also very easily to iterate through 4 directions by just doing this. I was wondering if we also do diagonal with this. Oh, we probably cannot do powers. Yeah, we can take a look at, but this is something. This is something else. This is something else. All right, that will be it. I'll get some good dose of Mr. Parkman. I'll see you guys tomorrow. Adios.